So today we'll be going a different kind of clustering. I don't think you all have done DBSCAN clustering, right? Okay, so today we'll be going into the next kind of topic, DBSCAN clustering. So this is a very common clustering that is used in the industry, and so there are some problem with hierarchical and agglomerative kind of clustering, and k-means kind of clustering, and that's why DBSCAN clustering is which you need to do in order to solve these kind of tackle these kind of problems. Okay, to introduce myself, I am Anirban, and I am will be your mentor for this session. And I have around 6 years of experience. I currently work with Oracle as a senior machine learning engineer. Yeah, that's all. My introduction is all about. I am a pass out of VIT Vellore of 2018. So let's get started. Just share my screen. Okay. So first of all, the algorithm that we'll be understanding is known as DBSCAN algorithm. And in DBSCAN, the majority thing about DBSCAN, the full form of DBSCAN is density-based clustering of application with noise. Okay, that is the main thing. And if you look at why DBSCAN is so popular, because it helps you to separate out noise, because in k-means clustering what happens is, guys, you have to know the number of clusters that you want to choose from before. First of all, that is a problem. And the second problem is, you cannot separate out noise. Let's say some points which are very far away from the main clusters, you cannot separate them out. So that's where DBSCAN comes into play, and DBSCAN has been very powerful in order to solve these kind of noise kind of situation. Okay, so DBSCAN is based on a very simple concept. Okay, so I will directly go into the sketchpad and explain you and draw and explain you, and then come back to these theories. Okay, and we'll look at the theory afterwards. Okay, so first let me go ahead and explain it to you through a sketchpad. Okay, just a minute. Okay, so DBSCAN, first of all, is based on the concept on very important five important concepts. If you know these five important concepts, you will be able to understand DBSCAN very easily, and you will be in a moment, you will be in a situation to explain DBSCAN in the interview also very easily whenever you set future in future. So first of all, DBSCAN has something known as EPS, also known as epsilon. It has min points. It has something known as code points. It has border points. It has a noise point. So in DBSCAN, there are something known as noise points also to separate out noise. Okay. So first of all, let's understand how it happens. I'll give you the picture how it happens. So let's say you have a situation like this, where you have clusters like this. You have points like this. Okay. And let's take epsilon equals to 1. Okay. So what is this? First of all, let's understand what is this epsilon. Epsilon 1 means just like a radius. Okay. So if I draw a circle of epsilon 1, that means this is what epsilon 1 is. Okay, this is what epsilon 1 is. So when I mention epsilon 1, that is means it's a circle of radius epsilon 1, the unit epsilon. Okay, It is nothing like meter or centimeter or anything. Epsilon is its own unit. If you give 2, then it will be a bigger distance. If you give 3, it will be a bigger distance. So epsilon, as you increase, the distance increases. Okay. Now things will be clear in a while. Okay. So first of all, let's say if I have a epsilon 1 and minimum points equals to 3. And what DBSCAN does is, whenever they see data points like this, what DBSCAN will does, it will take a random point. Let's say this is one random point, and within one epsilon distance, it will try to find a point. It will try to find these 3 points. Do I have 3 points, including itself, within one epsilon distance? Do I have 3 points within one epsilon distance? Let's say this is your first one epsilon distance. Okay, do I have that or not is what epsilon will try to look for. So this is the first goal of epsilon. And if, say, let's say if you have the distance, if 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 you already have these 3 points within that one epsilon distance, within one epsilon radius, then that means this point is known as a core point. So a core point is a point when you have minimum number of points, minimum or greater than that, within epsilon radius of that point. That is what a core point is. First of all, did you all understand core point? Can I get a thumbs up if you have all have understood what is core point? What is epsilon and min points, you all understood? Okay. So we are done with epsilon, min points, and core points. Now see, what is the next goal of DBSCAN is to look and expand this ideology of core points. So now, once it has found this to be a core point, now within that radius, it will look for the next one to be a core point. So next, let's say this point is the next point. Next point, it will look for that within 1 meter radius, within one, not 1 meter, one epsilon radius, do I have min number of points? Well, we have. So this is again, this also becomes a core point. Now it has started, engulfing everything. So now this also becomes a core point. Okay, because this also within 1 meter radius, it will one epsilon radius, it will also have the same thing. It will also have these 3 points. It will have like this. Now it will look for this. So like this, you are seeing that the DBSCAN is expanding. It started with 1 point, random 1 point, and it is expanding its area, its surface area of core points, the number of core points. It will keep on expanding. Now this is how core points expands in DBSCAN. This is the first logic. This is the first concept of DBSCAN. Next, I will go to what is border points. Okay, so border points is something which doesn't satisfy this logic of 3 points, but it has one core point within itself. Let's say, for example, let's say I take a point over here. Okay, I take a point over here, and within one epsilon, it will try to draw a radius. And let's say it has drawn like this. And let's say this one was a core point. For example, this one was a core point. Okay. Now see, within one epsilon, did it find minimum number of points? Tell me, guys. Did it find minimum number of points? No, right? It has only found 1 point. Including itself, it is 2 points totally. So minimum number of point is not satisfied. Right? Minimum number of points is not satisfied. So a border point is a point where it is not a core point, but it has one core point within its epsilon radius. Within its one epsilon radius, it has one core point. So since that is known, so since it has this 1 point, which is a core point, within one epsilon radius, then that is why this point is known as border point. Everybody clear with what is border points? And understood core point, border points both? And what is the difference? Okay, so now see guys, what happens is you have found border point, core points like this. Let's say over here also you have found one core point and border point. And mostly over here, everything is a core point only. You don't have a border point. That could be also a scenario. Okay, so this is one cluster and this is one cluster. Now, what is a noise point? What is a noise point? A noise point is a point which is neither core point nor a border point. That is what a noise point is. Neither core nor a border. Let's say this a point over here. Okay. Within epsilon radius, it doesn't have any points and neither it has close to a core point also. So this is known as a noise. But if you look at k-means will not be able to separate this out. It will always consider this also as a part of one cluster forcefully. K-means doesn't have a way to separate out noise points. But DBSCAN is specialized for that. So if you have a situation where you have too many outliers, too many points which could be outside the entire data points clusters, then use DBSCAN. And this is a very common practice industry. It's used in the industry. That is DBSCAN. It is specially designed for noise or class noise which couldn't be part of clusters. That is what DBSCAN specializes in. Now, if you look at the entire scenario, how it happens. Okay, let's say you have given 10,000 points. So how it starts off? First, it takes one point as a random. Then it starts to check within one epsilon radius. Do I have minimum number of points? Yes, I have core points. Satisfied. Now it will keep on expanding that core point to all the points that is within that one epsilon radius, and that's how it will keep on expanding, and all these things will become one cluster. Then a situation will come when it will not be finding any more core points, but it will find border points, border points like this, points which have one point within one core point within its epsilon radius, but it doesn't have minimum number of points satisfied. So first it will start with core points, then it will start expanding its horizon, and then it will keep on finding border points. And there a time will come when it will stop expanding and it will stop. Then it will go to the next random point which is outside this entire thing. So maybe here, let's say, again it will keep on finding, and then this will become one cluster and this will become one cluster, and whatever is left out is your noise. This concept entire DBSCAN is based out of. This is the entire concept of DBSCAN. Now, is it easy for you guys after hearing this? Can you all explain? Are you all confident enough to explain this entire thing? Can I get a thumbs up if you have all have understood entire concept of DBSCAN? Thank you. Thank you guys. Okay, so now we will go back to the theory part. So we are done with the sketchpad part, and we will go into the theory part. Okay, and we'll look at the theory for a little bit to get the definition in a concrete way. DBSCAN, density based clustering, is a density based algorithm. Okay, density is equals to the number of points within a specified radius, that is epsilon. A point is a core point if it has more than or equal to the specified number of points. That's what I told you just now. Min points within EPS, the like you need to have this many min points within that EPS, that is within that radius, then only it will become a core point. These are points that are at the interior of a cluster. Core points are, if you look at, if you saw the picture, if you saw the way I was explaining, core points are at the interiors. A border point has fewer than min points within epsilon. A border points doesn't satisfy the min points category, the min point, criteria, but it is within the neighborhood of a core point. That is a very important thing about border points. A noise point is any point that is not a core point or a border point. In DBSCAN, each data point is classified into three categories. Core points, data points that have sufficient number of neighborhood points within a specified distance, that is epsilon, are classified as core points. Border points are the points that are within a specified distance of a core points but do not have enough neighboring points to be considered core points themselves, are classified as border points. So border points are the points who were a candidate for a core points but couldn't become a core point. They are border points because they couldn't satisfy the min points criteria. And noise points are the points that are neither core neither border points, meaning that they are not within that specified epsilon distance of any core point. They are classified as noise points or outliers. So that is where the speciality of DBSCAN comes. Okay, so if you look at this, this is how the original picture of DBSCAN, our data points would look like. You will get now if you look at if you come over here, you will see that the interiors point, that if you see the green ones are core points. So it started with a random point over here. It kept on expanding, and then how it becomes one cluster. Okay, and the blue points that you are seeing, which are very near to the core points, are your border points. And the far away points, the red points, these couldn't satisfy the nearby criteria. So this became your outliers or noise. Advantages are DBSCAN clusters can have arbitrary shape and size. So DBSCAN can have arbitrary different kind of shape and size. So DBSCAN kinds of help with that. So number of clusters is determined automatically. Like K means you do not have to mention clusters over here. That is the biggest problem that you are solving. You do not have to mention clusters over here. It can separate clusters from surrounding noise. That is also one more thing. It has a specialty to separate out noise. And it can be supported by spatial index structure. So if certain points, what do I mean by spatial index structure is, let's say if your distribution has clusters spreaded like this, points spreaded like this, then DBSCAN is the best thing if your clusters are very uniform. But if your clusters are not uniform, then DBSCAN can be a problematic. Let's say if you have 20 points over here, and if you have 5 points in this cluster, and if you have 100 points over here, then DBSCAN can be cluster, can be problematic. And if they are not spherical in nature, let's say these are all spherical in nature, they are all forming small clusters, rounded clusters. But let's say if they are very much close to each other, there is not, there is no spherical structure to that, then DBSCAN can be problematic. So these are the fallacies of DBSCAN. Okay, I know people are having a lot of question. I'll just give you a time to answer. Answer your question also. I'll come to a situation where I'll give you a Q&A session also at the end. So just hold on tight for a little while. Okay, now comes to the few more disadvantages. In some situations, it's very sensitive to input parameters thing. So the input parameters that you over here you have to give is min points and epsilon. These are in your control that you can give, and this can be sometimes problematic, due to which clustering can be difficult sometimes. So you will have to try with different values, different combination of what epsilon you want to give, what min points you want to give. This min points I gave 3 in our example. The min points that you are looking, I gave 3, and epsilon I gave 1. But what value to give? This 3, 1, 1, 2, 3, 4. That is what is in your hand. So in some situation, it is very sensitive to what you give as an input. Okay, so these are the disadvantages of DBSCAN. But the best thing is it can separate out noise. Okay, so now we will go back. We will go to the practical side of it, and I will show you how DBSCAN works. Okay, so first, this is how we I have started. I started this notebook with first the to show you some points, some random points I have taken. Okay, so these are the points that I have taken. You can see 1, 2, 3, 4, 4, 3. All these threes are very close to each other, and then you have 8, 7, 7, 8. These are again close to each other. These 2 points are close to each other, and then you have a very far away point I have taken. So what I have imported is I have imported from sklearn.cluster import dbscan, and from matplotlib import pyplot as plt. So to plot all these points. Okay, so these are our points, and if you plot them, this is how This is how your clustering, this is how your points looking like. Now, can you all tell me how many clusters can be formed and how many noise can you see from here? How many noise you all can see from here? How many noise points you all can see? Amongst these blue points, how many noise points you feel like? Two clusters, one noise. Very good, Pranav. Very good. Okay, guys, if you have any question, please drop in the chat box. Okay, I will take them up once we are done with the entire thing so that the flow is not disturbed. Okay, so yeah, we can have two clusters and one noise, or on a broader sense, we can have even one cluster and one noise also. That also can be a possibility. Okay, so first, what we will do is let's do epsilon 1 and min sample. Let's do 3 and try out. Okay, so this is what clustering is. You just create an object. Clustering equals to DBSCAN, epsilon you mention, and min sample. These are the two things you'll have to mention. Dot fit predict, and you have to pass all the points over here. Just do this. Okay, so we are getting all as -1. That means it is considering everything as noise. Okay, now let us try increasing this. Okay, so see, when I have increased, the min sample to 1, every point of its own is a cluster because it is considering one point only as a min sample. So let me increase the epsilon to 3 and min sample to, let's say, 3, and let me see now. Okay, now it is considering first 3 point as one cluster and all the rest of them as noise. Okay, so let's do 2 and min sample as 2. Let me keep also that's 3. Yes. See, as we have changed, I have told you input parameter, as you change, you can see different versions of it. So now see, I have made epsilon as 3. So within 3 radius, do I have two minimum samples, min points? Min sample is the min points. Do I have two minimum points? So within the 3 radius, do I have three? Within 3 radius, do I have 2 points? Yes, I have. This is a core point. This also becomes a core point of that point. This also become a core point of that point. After this, it stops spreading. Again, it starts from here and try to satisfy. So we have two clusters. One is this, other one is this. And then can you see a -1? -1 means that is not a cluster, that is a noise. The -1 that you are seeing is a noise. So we, from this points, you can easily identify the points, the clusters from using DBSCAN, and you can also identify a noise. Now, guys, if you increase the epsilon, the number of cluster will increase or decrease. Tell me, if I increase the radius size, the number of cluster will increase or decrease. Guys, tell me in the chat. Let's see, like how many of you have understood. Think wisely, guys. If I increase the radius, the cluster will increase or not, or decrease. I got two answers as of now. Anybody else? You only think that if you increase the radius of you expanding more points within you, then will the cluster decrease? Yes, decrease is the answer. Decrease is the answer because see, if you increase the radius size, if you increase the epsilon from 1 to let's say 9, then the radius will be too big. Then everything will start becoming within that cluster, right? As it starts expanding, everything will start becoming within the cluster. So the entire 5 points that you're seeing as blue, starting 5 points, all these things will become one cluster only. And since this is too far, then it can be a separate, still now it can be a noise. See, everything has become one cluster, cluster 0. This has become a noise. So it's all the game. The game is entirely lies in epsilon and min sample points. Okay. Now we will try to understand a little bit of more differences from k-mean. Uh, so first of all, in k-means, guys, what happens is, just a minute, guys. Just give me a minute. Just a minute. I'll create some clusters for you all so that you all understand. Just give me a minute. Yeah. Okay. Okay, so now first of all, the important difference from k-means. Okay, so let's see if I'm doing k-means. First of all, you have to mention clusters over here. You do not have a way out. You have to mention the number of clusters you want over here. Okay, now if you want to see the clusters, okay, let me play this back again. Now see, guys, if you want to see the clusters, see, guys, there are two clusters k-means is able to create because I have mentioned two. But k-means is not separating the noise. It is also treating noise also as a cluster. Okay, it is also treating noise also as a cluster. So it starts to create k-means. The problem of k-means is that only it starts to even consider noise also at a cluster. So it is even this one is also a part of a cluster only. There are two clusters over here. One is zero. All these are zeros, and all these are ones. All these are ones. One point is there, that is also one. And if you look at it, there is a, if you do k-means dot cluster centers, you will get the center of k-means also. If you play, you will get say center of k-means also. Now if you want to predict a new point, it will just calculate the distance from this and it will put them in that cluster. So obviously if you put these points, it will be part of the this cluster because this is more closer to this point, the point that you are seeing over here. Because these points, if you are putting, see, 2481 and 2385 will be more closer to the point 2580, right? So that is the thing. Like k-means, if you look at it, there is no logic. And k-means, whenever you give prediction, it predicts with the distance calculation. Okay, but DBSCAN, on the other hand, DBSCAN, when you are predicting, it again creates a cluster and comes back. It again creates a cluster. DBSCAN doesn't do prediction on the go. So when you are doing prediction with DBSCAN, it doesn't predict like k-means. K-means calculate the distance while during prediction and gives you the answer onto which cluster it belongs to. Whereas DBSCAN, it will, when you are doing during the prediction time, it will again consider those points that you are giving for prediction into that entire points distribution, and it will again count the entire clustering. It will do the clustering. Okay, so for example, let's say you have a distribution like this on which your DBSCAN is trained. Okay, you have two clusters. This your training is complete. Now, if you give a cluster to it, a point to it, next time again DBSCAN will not count a distance from these clusters. It will again start doing this calculation of DBSCAN, and it will, so every time you are trying to do predict, it is doing training only and predicting at the same time. So DBSCAN considers all these points together and then do the prediction. So DBSCAN doesn't have that predict method like cluster, like k-means. So there is no application of learning in this concept over here. Okay, there is no learning from beforehand. So when you are doing prediction, again it tries to do the DBSCAN calculation, which I showed you. Okay, so over here I am creating some synthetic samples. Okay, I'm using this make blobs library module from sklearn to create some 200 samples. So see, I have created some 200 samples. Okay, we have 4 centers, so that means 4 clusters. Okay, and each cluster has a standard deviation of zero 0.6. Okay, so this is like synthetic points I have created, clusters I have created. Okay, so you can clearly see 4 clusters. Okay, and now we will do this DBSCAN again, just like the same one. Okay, and I have considered epsilon as 0.4 because the points are very near to each other. Okay, I have considered, and I have created the clusters. If you look at it, we have 5 clusters we have created. And if you want to see how good is your cluster, you have to check the silhouette score. This is the silhouette score, 0.42. Silhouette score ranges between -1 to +1, guys. The more it is close towards +1, the more better it is. So you will try with more higher epsilon. Okay, try with 0.5. See, silhouette score is increasing. But it doesn't mean that if you keep on increasing epsilon, it will keep on increasing. It'll keep on increasing. But yeah, when I change from 0.4 to 0.5, it increase. So you will have to do a hyperparameter tuning to find out the best epsilon and min sample, and then keep on checking your silhouette score. Guys, everyone understood DBSCAN and their practical implementation? Can I get a thumbs up? Thank you, guys. So now, guys, I am opening up the forum for questions. Okay, so could you write down questions that you have in the chat? Could you write down in the chat anything related to industry related thing? I can help you answer. You can ask me anything regarding placements, anything, guys. Not only DBSCAN, anything outside DBSCAN, career related thing also you can ask me. Okay, and I can guide you at this point. Any question, guys, you all have regarding career, regarding placements, regarding anything that you all face? So for data science, only Python is enough or some other language? No, no, no. Python is enough. You don't need to do anything. And obviously, a little bit of SQL also you need. So, like, but that is not so mandatory also, because some company, depends on company to company. I have worked in 4 companies. Out of them, 2 required SQL. Others didn't require. So SQL is like very less chance, but Python is the backbone. And if you know Python, you can do even the SQL stuff at Python also using pandas. So even let's say if you do not know SQL, and if you get an interview question or the interviewer asks you, then you can always tell, I can solve the same thing in pandas. So if you can give me in pandas, even the interviewer itself tell them by themselves that The interviewer only asks like, can you solve this in pandas if you don't know SQL? They only give you the chance because they also understand that there is a chance that you might not know SQL. Is C language important? Not at all, Kunal Srivastava. C language is not important at all. It is nowhere important. Doesn't come into the entire game of uh, your data science. It's a primitive language and it is not used in data science. It doesn't have the capability to create data science related solutions. Anybody like this career type of question you all have, then I can take up. And guys, since DBSCAN was not there in your main sessions, to do not take it lightly, also prepare this because see, everybody will go through the rest of the clustering algorithms. If you know DBSCAN and if it is not part of your module, then you stand out of the crowd. Okay, so no DBSCAN, guys. Many people do not know DBSCAN when they start off. You know it. Okay. Shahid, can you give me like which year you are in? Pravan, see anywhere, see whenever you are doing clustering related solution, okay, always do all the three clusterings. Always do k-means, agglomerative as well as dbscan. In machine learning, guys, there is no fixed approach to where a particular algorithm can be used. Obviously, during learning, you learn that okay, this can be used here, this can be used here. But we do not go by this bookish method and apply only where it can be used as we learned it. We apply everything and then we see, and wherever we find the best, that one we choose. Got it, Pravan? So you try it whenever you are doing clustering, do all of them. Do agglomerative, k-means, and this. Okay. Shahid, as a first year student, what I would do is I would see, first of all, it is too early to worry about you about a data science roadmap, first of all. So let me give you that, you can, don't need to worry about it so much as of now. So your goal should be to be very strong in your Python stats as a college student, because machine learning is based on these two things. Stats and Python are the background. Python on which you do the implementation. Stats are required to understand the algorithms. Okay, so your goal is to prepare Python and very be a beast in Python in next 4 years, 3 to 5 years, or 4 years, and have a nag for all these AI and all these things. Like you should, keep on looking at problems, how the world is working, how Gen AI is working. You should just read up. You don't have to go very technical. Okay, very technical also. Just read up. Okay, and the module in IntrnForte is enough for you to become a data scientist. Fresher, as a fresher. Okay. And Gen AI, you don't need to go technical, but you can, see videos, how Gemini is working and all these things. Don't need to go technical, but at least have the interest, I would say. Nag means interest, like little bit in your mind. Okay, Gen AI works, does this, does that, does this, does that. This kind of interest you should have, so that your interest or your motivation stay alive. Okay, for next 4 years. So my ultimate thing that I want to convey is your Python and stats should be very strong, and you're obviously you have done your courses from IntrnForte, so that part is anyway sorted. But otherwise, in order to keep your interest or your motivation on, you just keep on looking how AI is changing the world from a normal person perspective, not as a technical person. Okay, got it now, Shahid? Thank you. Okay. Anybody else? Any more questions? Okay, if no question is there, guys, thank you everyone. I will just wrap up this. Thank you for being a good audience, and it's great that you all have understood DBSCAN. Thank you, guys. Bye, everyone.